Hi Tant, Happy New Year, hope you had a good time. My diesel dryer, clothes dryer update. The old dryer fell to bits. I'm not surprised really, it's only had 2 years worth of use continuously. I thought, right, buy another drum, but the model number can't get hold of the drum anymore. One on eSpares, brilliant setup, brilliant site. Drums from as little as 66 quid. So I thought, great, but then I looked into it, there were 3 kilo drums, and I needed the 7 kilo drum, so I thought, okay, look, what's the point? So what I've done is I've now bought a new, cheapest 7 kg dryer I can get for 216 quid delivered from AO.com. And this is a video of basically converting a new dryer using the bits from the old dryer, and see what you think. Cheers. Here's a dryer, just been delivered by AO.com by two very nice blokes. Kept me well informed. To be fair, AO are really good. So this is an Amica 7 kilowatt, 7 kg item. So I'm going to unpack it. Right, this unit, I think it was about £218 delivered off AO.com. See that it's got some good features. I mean, my system's basically a 12 volt DC motor, and that will just drive all motors on these machines now are alternators, basically not alternators, but they're not brushed, so you can drive them without doing too many mods. Like I said, 7 kg capacity. I know it's only a dryer, I can't make this exciting, but there's the energy ratings C, it's not particularly good. But as we've got the dearest energy in Europe, and you know, I'm a landscaper, my partner, we're always washing clothes for work. So having this diesel powered and 12 volts powered is massive. But I'm going to weigh up now. I'm going to take the back off, weigh up. I'm going to not try to mod this too much. I just want to add the motor, add the feed from the diesel pump. Basically just blows hot air into that chamber, and that is it. Goes through those vents, comes into here, comes out here. This fills up. This fills up on now. In the dining room on the table, but it's only a dryer. Filled it up. 3 hours on maximum heat. Mixed materials, extra dry. And I've also got, I'm going to press on now. Put a load on just to test it. And that's running 822 watts an hour. So it's 1 o'clock now. It'll be 4 o'clock by the time it's finished. And on my smart meter tomorrow I'll be able to see how much that costs me at a datum. Well, that's wrong. Got it wrong. That was kilowatt hour. That was counting how many kilowatt hours it's going to take to run. It's actually taking 2.2 kilowatt. 2.2 kilowatt an hour. So in 3 hours that'll be 6 kilowatts. And I'm sure that's to work out the math, but that's going to cost us about 5 quid. I'm sure it's going to cost us a lot of money anyway, so that's why I did the diesel dryer in the first place. Right then, I've taking the back off this. Here's a drum. This design's slightly different to the other dryer I did, which is a bit better, I think. So behind this panel here is a heater element. So the big heater element going around there in a coil. And basically what it does is I'm going to keep where the drill is, the motor, the 12 volt motor, I'm going to put the 3D printer bracket, 12 volt motor will go in with a coupling, So keeping all this as it is, and what it does is this fan unit here sucks the air through here, making the vacuum in the drum, and then obviously pushes there's a filter. I'll keep all that, and it pushes the air through the snail air coming out, and then exhausts the dry and close the vapor. So technically this is going to be a better design than the other one I had. All I've got to do is I'm going to take this off the back here, take the elements out and salvage it. I'm not going to destroy it, but I'm going to have to make a hole here, tack off the old unit the input coupling going in there, the U-bend, so the hot air will go into this chamber here, which would be normally, so the diesel heater is basically replacing the heating element that's in there like a kettle. So instead of 2.2 kilowatt an hour, it'll be using the diesel fuel or heating oil, whatever. Yeah, and this is where you're saving the money. But I'm going to keep all this, bag all this up here, tidy it all up, because I want to keep all that, so I don't want to destroy anything, and try and keep this as factory as possible. So all I'm really doing is adding an alternative heating source to here. Yes, it hasn't got, these are sensors to make sure it doesn't overheat the clothes, but 2 years I've been running the other dryer, and you get used to, you put a timer on your phone, you just periodically check it every hour. That's all you have to do. I mean, don't get me wrong, cracking bit of kit this, but if I want to use this twice a day, it's going to cost me £6 a day to run this. Basically it's £1 an hour, around about £1. It's about 68p an hour. So do the math. I think it was £1.93 for 3 hours. If you use it twice, £4 a day. Say you use it 15 times, you're talking about 60 quid a month extra that you're having to pay. Yes, you have to buy diesel, I'm not denying that, but the 12-volt motor that's running this only runs at maximum 250 milliamp, so it makes a massive difference. Put it this way, the dryer's been used constantly, and I haven't seen it on the electricity side of the bill. And it's just an alternative, the lights go out, you can still dry your clothes. So there you go, on 12 volt. Because these diesel dryers just work on 12 volt. This just works on a 12 volt system. This can run off a car battery. You can't do that with a normal dryer. Here's effectively the heating element. So that gets hot, and this whole chamber gets heated, and then that is then sucked through those vents. Quite a simple system. In fact, this seems a bit more crude than the other one I had, really, because it had a seal inside there, but obviously they don't think they need to warrant it, but there's quite a big gap between that and the drum. But yeah, obviously it's sucking, that fan unit there is sucking the pressure, the drum pressure. So it's coming through there, going through there, and coming out of here, which will be the output. So that's why it's called a vented out dryer, or vent out dryer. So this isn't a condenser one, this is just a crude, basic dryer. Ideal, really. Not much to them. So another part of this video, this is an update. There's the 12 volt motor. That's 350 watt motor, 36 volt, but I'm running at 12 volts. I've got a coupling coming from shaft to shaft there, if we can just zoom in. I've 3D printed, made a bracket, it's 2 colour, because I've just used a couple of spools I had lying around. Is it in focus? Please focus. Yeah, so that effectively powers the existing fan unit. One thing I thought of, I've got a circuit that reverses. This dryer doesn't have that feature anyway, and there's a bit slagged off on the review saying, you know, it tumbles one way and spins all your clothes into a ball. So I got around that because I've got a circuit and it went backwards and forwards every 2 minutes. So technically what that'll do though, it will reverse that fan. So instead of coming through here and exiting the damp clothes and the damp, then it technically could put it back up here. I'm not sure yet, so we'll see. I'll see how that works. If not, I'll just have it going one way. But I'm going to make some bits on the 3D printer for this, and my steel hole cutter come today. That was only £8, and then instead of bodging, I've actually got a proper coupling. That was £4. Couldn't make that for £4 if I tried. So I'll make a silicone gasket to go in between there. Position that where I want it. Bolt it down to the weld in it. So, but obviously cut out the hole first for the vents. Then place that over. And then that's my input for the heat from the Chinese dryer, Chinese heater. So it's another part of the video. Hi, next part of the video is what I'm doing here. I'm putting the vents. So I've marked out, got the holes on my little new unit there. And then also, all I've got to do, I've done my 3D printer thing as we know. The coupling came today. I can't get one. Well, I probably can. I'll have another look, but I'm just going to drill out. That's 10mm, and that's 8mm, and I need to update that to 12mm, and then I can put the coupling on. I can put that motor, fix that down onto the base there. Get this out of the dining room because my partner's going nuts. And I did run this, and I think if I were to run it with the rates I'm with Ovo at the moment, you're talking about £4 a day, and maybe every other day might be in use. You're talking about 45 to 50 quid a month, where diesel and 12 volts is half of that easy. So I'd be even more efficient now with this new system. So another part of the video. Hope you're liking it. I've drilled a hole using the hole saw there, so that pretty much lines up. I'm just going to take that part out there, and then make a gasket out of silicone. I'll use silicone sealant. To be honest, silicone easily resists the heat that's going to be coming through here. Don't use a rubber gasket, don't use cork, don't use anything. It's got to be silicone, if anything. Doesn't necessarily need a gasket. It's not like it's a sealed unit, because the rest of it, it's just like an air flow, but I'm just going to try and help it as much as possible. Get a few bolts, bolt that up, get a bit of silicone it up. Looking good. I bought a coupling now. I'll just show you this coupling here. That is a 10mm to 12mm. I originally bought that one. That's no good. 10 quid. One's Amazon, one's eBay. CNC Robotics thing, you know what I mean? So that'll go on there. And I've got a 3mm spacer made. And then the motor. What I call a PCD. It's basically that goes on there. Get your coupling from the motor, keeping everything as it was. So if I got to reverse this and I don't want to use this anymore, I'll be able to just put it back to how it was when I bought it. Make sure the belt's on there ready to go around the drum. So another part of the video. I'm running the just testing the motor now, just mounting it. That's running 18 volts at the moment. That noise is just tin wear. no vibration on that coupling, so the PCB should be pretty good. And then there's a flow of air coming out of here, which is extracting through the drum, going down through here, and the vapor and the moisture coming out this way. So happy with that. I'm not sure what it's going to do when it goes the other way around with the cycle system I've got, but there you go. I'll be checking that out. It's me worrying about screws protruding and extras, but when you look at the build quality from the factory, I've got nothing to worry about really. So there you go. My flange is on. So just cut down those studs, just tidy up a bit, and this can go back together now. And my partner can be happy because she's not very happy with this in the dining room, but it's better than freezing -4 in the workshop. So even though I've got a heater, I think I did totally wrong is try and put the drum in, try and put the belt in, and try this bit. Managed to get the belt on, and if you're gonna have a go at this is my kind of idea, and don't copy me because I'm an idiot, but this is what I've done so far. To get that belt on, you need to take that off. Quite easy. There's like keys in here, not keys, but retainers that go into the metalwork there. So take all that off, and it's quite easy. You see the drum, and then you can wrap the belt around, and there's the guide there, making sure the belt has the belt's got grooves in it, so the grooves go onto the drum side, so don't have them the other way around, because they feed on a spindle on the shaft down there. I don't know if you can see that. And then you've got the tensioner. So yeah, that's all good to go. So I'm just going to test it in the next part now. Here's a 12 volt dryer motor in action. There you go. Obviously running a bit too fast. And then you've got airflow. Airflow coming out of that's the pump. Ooh. So I'll pull all that back together now. The technique I use, I've got to just drill one more hole, and that's for the vents for this, coming out of the back plate here. So I'm a landscaper, so what we normally do, I'll put a line across there for the horizontal axes, and then the vertical axes I'll line up, get it pretty much spot on, drill a hole in here. So I've only done 2 holes with this, is here and here. The modification, coupling and the 12 volt motor there, and I've kept everything as it is, so I can strip this back down. If I need to put it back to electric, got all the photographs of where everything was, kept everything as it was. So technically all I've done is modify this and put a hole in there and put a motor on the existing shaft, but the rest of it can go back to being an electric dryer if needed. So that was the point of this project and this exercise, which I thought was quite important. The first one I did, the thing was scrap anyway, so, and I've learned a lot anyway, so there you go. There you go. Right, that's all come together. Testing it before I took it outside. And I've got my key to 18 volt because I can. It's a 36 volt DC motor now. Loads of air flapping off that. Cool. That'll be good. So all effectively I'm going to do now is put my diesel dryer spine off the other one down here somehow, and that's it. And basically somehow put the ducting through to the diesel heater. Diesel heater blows hot air through there, goes through the drum, and should be far more efficient than my first Mark 1. So that's super cool, that. And as you can see, it's quite OEM, quite tidy. So it's only this has really been adapted to the motor. So that is a 12 volt dryer based on that model. £225 thing. And like I said, that can go back to as it was if needed, and all I need to do is blank off the plate, blank that off here, and take the coupling off the 12 volt motor and go back to 240 volt, which when I was running was 450 a day for 2 sessions on that, so it's well worth doing this. Nice to put the diesel dryer brace on there, a couple of screws there, a couple of screws there. Ideally, I think I might have put that down a bit further, but it doesn't matter. That's the plate that the diesel dryer goes on. So next stage. That's the diesel heater system fitted, so just need that to there. Another phase. That's a fluke. Ideally I should put it a bit further down there, but airflow's not too bad. So I'm going to coat that now with aluminium tape just to keep the heat in as much as possible. But that just blows hot air through, converts the diesel into hot air, that's it. I'll come out the bottom here as vapour and run the motor there, 12 volt. And that's 12 volt as well. NASA's just called up, just asked me to do some wrapping on one of their new space modules. Anyway, aluminium foil tape from Tool Station with a little phase there. Right, that's only there temporarily because I've tiger sealed that against, so you can easily peel tiger seal off and keep that fresh. So I'm not drilling holes into the metal there to hold the tank, but that will hold the tank well. But I will do some 3D brackets underneath and bond them underneath, to be fair, to give it a bit more stability. Again, that's just to keep that in place. So the tiger sealed the controller in place. Well, the controller box are 3D printed. Wiring's all done. I've got a switch coming for that. Exhaust input. So the next thing is to test it. Well, that's working all right. Temperature's coming up there. All the electrics are just dormant. It's not 240 volts. There's no AC on this now. And there's the drum inside. It's got auto reverse. The circuit I've got, I can put the circuit on. That's crazy invention. For that, nice and quiet. I was running the drum on rollers, and then as the drum was going over the rollers, a clacking and banging, not very quiet, but you can see air filter on this as the turbine works. Better shut it down. It's on full whack at the moment. Let that cool down now. So that's a successful little run, and I'll take a bit more of a video of clothes drying and see if it's any more efficient. But that now is warm air will come out of there now with moisture, which the other one didn't do. I was just venting out of the drum. So yeah, thing's pretty much standard unit with this this snow on. Another part I've just added is the pipe that goes round the exhaust bit as well, which is ideal. And that concludes my conversion. And it lives outside here. There's a little roof, and it means that will work now, and clothes can stay inside the drum, and it's a standard dryer now. My old dryer did rip a couple of clothes, and that runs a Chinese, that's an IP66 box. Power goes into there, 240 in, 12 volt out, so that's just a 12 volt power supply. Once that's sealed up, I'll take the tape off. Controller, just got a pipe to go on there to the filter there. And thanks very much for viewing this channel, and some more stuff coming on. That's now running. Just the end of the video here now. Just so I'll show you. This model of dryer doesn't have only rotates clockwise. Doesn't have an anti-clockwise. So that's a standard dryer now. And my timer every couple of minutes goes either way just to stop it balling up. That's working okay. That's the fuel. All working. Just going to be careful with the temperature, because if this is efficient compared to the other units, I'll just monitor. I'm going to make a sensor that will automatically probably turn this down.